Hello my friends and welcome back to the You Can Do TV channel. Glass is a very common material in modern life today. It appears everywhere, on the window where you are working, on the glass of water you are drinking, on the chandelier hanging in your house. Have you ever wondered how they are made? In this video You Can Do TV channel will explore it with you.
This silica sand washing plant was installed in Vietnam. It operates as a cutting-edge beneficiation facility, converting low-value material into high-grade glass sand suitable for various industrial applications. This plant is equipped with advanced mineral processing systems designed to optimize sand specification while minimizing environmental impact, ensuring both efficiency and sustainability. The process commences with the efficient transfer of material from the feed hopper facilitated by an integrated belt feeder and belt weigher, ensuring precise material handling. The atropure attrition cells, dynamic attrition scrubbers, play a crucial role in the process by efficiently removing contaminants, thereby maximizing product yield. Operating at 80% solids concentration, these cells ensure thorough scrubbing while minimizing power consumption, contributing to cost efficiency. Following the initial scrubbing stage, the sand undergoes further refinement through the ScreenMax Precision Fine Rinsing Screen. This component is crucial for superior screening, classification, and dewatering performance, ensuring that the final product meets stringent quality standards. The subsequent stage involves the utilization of Spiropure spiral gravity concentrators, which provide accurate density separation to remove any remaining impurities from the final sand product. This step is essential for achieving the desired level of purity and quality required for industrial applications. Further refinement occurs with the Vertimax upward flow classifier, which classifies particles based on size and specific gravity, thereby upgrading the feed material to meet optimal quality standards. Additionally, the Hydromax Water Recycling System, WRS, plays a significant role in enhancing sustainability by delivering high water recycling rates, minimizing environmental impact, and reducing the space required for settling ponds. The superior sand dewatering system, including the CentraScreen dewatering and sizing system, ensures that the washed sand is market-ready, maximizing revenue generation. Moreover, innovative sludge management technology accelerates tailings drying, reducing the tailings footprint and allowing for quicker water recycling, further contributing to environmental sustainability. Horn Glass Industries, in collaboration with Tepe Turkmen, is spearheading the construction of a cutting-edge glass manufacturing complex in Turkmenistan, situated near the capital city of Ashgabat. Spanning across an impressive 240,000 square meters, this state-of-the-art facility is poised to produce approximately 8 million square meters of float glass and an estimated 95 million bottles annually. The strategic location of the plant offers logistical advantages for both input supplies and product distribution. The glass production process at here begins with the treatment of raw sand to meet the stringent quality standards required for glass manufacturing. In the batch plant, sand, the primary component, is meticulously mixed with other necessary raw materials, including recycled colored glass. This carefully crafted batch is then transported to the furnaces for melting. Within the furnaces, the batch undergoes a transformation as it is subjected to temperatures reaching around 1,600 degrees Celsius, resulting in the formation of molten glass. This molten glass is then poured onto a bath of molten tin, where it forms a continuous glass ribbon. From there, the ribbon is pulled out using lift-out rollers and enters the annealing layer. In the annealing layer, the glass is gradually cooled down to the desired temperature, ensuring proper crystallization and minimizing internal stresses. Quality checks are conducted at various stages, and the glass ribbon is cut into different sizes to meet specific requirements. The processed glass sheets may then proceed to further treatments, such as coating and edge finishing. In the coating line, multiple layers are applied to the glass sheets using a sputtering process under high vacuum conditions. Following this, the glass undergoes conventional edge treatment to refine its edges. Additionally, annealed glass can be further processed through a heating and rapid cooling process to induce compressive stresses on its outer surfaces and tensile stresses on its inner surfaces. This process enhances the glass's strength and safety properties, making it suitable for various applications. The factory also specializes in the production of laminated glass, which involves bonding multiple sheets of annealed or tempered glass together with a PVB interlayer. The assembled layers are heated under pressure to create a durable and secure final product. Furthermore, the facility includes an insulation glass line where single glass sheets are combined with spacers to create insulated glass units, EGUS. These EGUS are filled with gas to improve their energy efficiency, offering top-quality products made in Turkmenistan. In addition to flat glass production, the factory is equipped to produce container glass. Molten glass from the furnace is distributed to multiple hearths, where it is formed into individual containers using pressurized machines. These glass containers undergo cooling, quality checks, and packaging before being shipped out for various applications, including participation in prestigious events such as the Asian Indoor and Martial Arts Games.
How glass bottles are made. Step 1. Raw material preparation. The journey of a glass bottle begins with the raw materials. Sand, soda ash, limestone, and cullet, recycled glass, are carefully selected and prepared for the manufacturing process. Step 2. Batching and mixing. The mixing process is crucial in ensuring consistent quality across all batches of glass bottles. Accurate proportions of the raw materials are measured and blended to bring the bottle design to life. Step 3. Melting. The mixed raw materials are then heated in a furnace at an astounding temperature of 1,600 degrees Celsius. This process results in the creation of molten glass, known as GOB, which represents the original form of a glass bottle. The glass furnace operates around the clock to maintain stable temperatures and minimize energy waste. Step 4. Blow glass forming. Once the glass is in its molten state, it undergoes the blow forming process to shape it into the desired bottle forms. There are two main methods employed for this purpose. A. Blow and blow process, used for narrow glass bottles like beer, wine, or soda bottles. Compressed air is blown onto the molten gob, pushing it to take the shape of the mold. The initial shape, known as a parison, is further reheated and inflated with more air to achieve the final shape. B. Press and blow process, primarily used for wide-mouth glass containers such as vases, candle jars, or milk bottles. When the molten gob falls into individual sections, a plunger pushes it to fit the mold, creating a parison. The parison is then transferred to a blow mold, where it is reheated and blown with air to reach its intended shape. Step 5. Annealing. To ensure the strength and durability of the glass bottles, they are subjected to annealing. The bottles are carefully moved into an annealing layer, a long kiln. Inside the layer, the glass bottles are slowly reheated and then gradually cooled to a temperature below the strain point of glass, minimizing any potential internal stress. Step 6. Quality check. At Roetell, quality is of utmost importance. Experienced quality control (QC) experts meticulously inspect each bottle for any flaws or defects. Bottles with imperfections such as split finishes, crumbles, deformations, molded seams, out-of-vertical finishes, hammered appearances, thin walls, blisters, or cords are automatically removed from the production line. Step 7. Surface treatment. After passing the stringent quality check, the glass bottles undergo surface treatments to enhance their appearance and functionality. Step 8. Packaging and delivery. The final step involves packaging and delivery. Glass bottles are delicate during transport, so the warehouse department ensures that they are appropriately stocked and protected before being shipped. Hofmann Glastechnik has been a prominent player in the production of scientific, medicinal, and industrial glassware for over half a century. With a perfect blend of traditional technical glass-blowing techniques and modern industrial production methods, the company has established itself as a provider of the highest quality glass products. Their expertise ranges from supplying stock laboratory items to crafting individually customized products, catering to diverse customer requirements. One of their standout achievements lies in the manufacturing of high-quality X-ray tubes, a field where precision and reliability are of utmost importance. To achieve the level of excellence required for X-ray tubes, the company employs SBS-controlled lathes that guarantee impeccable quality assurance. This cutting-edge technology enables precise and consistent shaping of glass components, meeting the stringent demands of the medical equipment manufacturing industry, where reliability is critical. Furthermore, the production process is a combination of hot and cold techniques, meticulously executed to create products of the finest quality. The fusion of metal and glass under high vacuum conditions is a specialized skill that requires years of experience to master. Hofmann's seasoned artisans have honed this craft, ensuring that the bonding of metal and glass in their X-ray tubes withstands the demanding conditions of medical and industrial applications. Quality and efficiency are paramount within the production line of company. By prioritizing these aspects, the company has earned a well-deserved reputation as a preferred supplier for the medicine equipment manufacturing industry. Their commitment to excellence has also earned them international recognition as a premier manufacturer of high-quality X-ray tubes, serving the medical and industrial sectors worldwide. In the heart of Mexico, skilled artisans gather to demonstrate their artistry in the mesmerizing craft of glass blowing. With deft hands and years of experience, they fashion a remarkable multicolored glass pitcher. As the fiery furnace dances with molten glass, the artisans carefully manipulate the material, skillfully avoiding even the slightest misstep that could lead to starting over. The result is truly stunning. A hand-blown glass pitcher that showcases the brilliance of confetti-like patterns within its crystalline curves. In a celebration of sustainability, the artisans utilize recycled glass to fashion this fiesta of colors, destined for the prestigious Novica hand-blown collection. Every step of the creation process is a testament to their dedication and mastery of glass-blowing techniques honed over countless years. No two pieces are exactly alike due to their handcrafted nature, and each pitcher may exhibit subtle variations in shape and size, with tiny bubbles nestled within the glass. This only adds to the allure, exemplifying the uniqueness of hand-blown craftsmanship and ensuring that every pitcher is an extraordinary piece of art. At Roetell's manufacturing facility in Kufstein, Austria, master glassmakers individually handcraft and hand-finish each glass. Skilled glassblowers gather a small amount of the molten glass onto the end of a blowpipe, creating a molten glass bubble. They use their breath to blow air into the pipe, shaping the glass bubble into the desired form for the bowl of the wine glass. The glassblower manipulates the bubble using various tools and molds to achieve the precise shape required for the bowl, ensuring that it complements the specific wine varietal. After forming the bowl, the craftsman moves on to create the stem and base of the wine glass. This requires additional glass manipulation and shaping techniques to achieve the desired height and stability for the glass. When it comes to the production of Roetell sommelier wine glasses, content commands shape. Claus J. Roetell, in the late 1950s, introduced and developed wine-friendly stemware, focusing on delivering the wine's bouquet, taste, balance, and finish to the senses. This principle led to the concept of grape varietal-specific glassware, where the shape, size, and rim diameter of the glass bowl are finely tuned to translate the wine's message to the human senses. Different sensations, including bouquet, texture, flavor, and finish, are enhanced by using the right stemware. The architecture of stemmed glassware is vital in ensuring the perfect harmony of size, height, and width. The ratio between the bowl size, stem height, and base width is carefully calculated, resulting in visually appealing and seamlessly proportioned glasses. Stemware featuring this construction is influenced by classic Viennese, French, and Irish designs. Once the glass has been formed, it undergoes an annealing process. The glass is slowly cooled in a controlled environment, typically in a special annealing oven, to relieve internal stresses. This step makes the glass more durable and less prone to cracking or breaking, ensuring the longevity of the finished product. Excess glass from the blowing step is carefully cut away to create the mouth of the cup, providing a smooth and refined finish. The wine glasses are then polished to perfection, ensuring that they are free from any surface imperfections. This heat treatment process helps to enhance wine glasses' durability and clarity. After the final inspection, the glasses are carefully packaged to protect them during transportation and distribution. The manufacturing process of the finest glass begins in a furnace, often referred to as the beehive, capable of cooking 12 colors simultaneously. Inside this furnace are ceramic fire clay pots, known as crucibles, each capable of holding around 1,400 pounds of chemicals. With 12 crucibles in the furnace, it can produce a large quantity of glass at once. Once the glass is melted to the desired consistency, it is carefully ladled and brought to the mixing table. Here, skilled workers deposit the molten glass and step back. The table man takes over and skillfully mixes the glass using a two-pronged fork. Once the glass is blended to precise specifications, the table man picks up the molten mixture and feeds it between two rollers, similar to rolling pins, which mash the glass into a flat sheet, approximately 1/8 of an inch thick. The ladles used by the employees are quite heavy, weighing between 20 to 50 pounds when empty and doubling in weight when full. The table man signals the L-adlers when it's time for the next sheet of glass by ringing a bell approximately every minute and a half. The table itself is made of a heavy steel mix, cooled by water inside to begin the cooling process. The two rollers are also hollow and air-cooled inside. Once the glass is rolled out to the desired thickness, it changes direction and enters the annealing layer for the final cooling process. This meticulous and labor-intensive manufacturing process ensures the production of the finest glass, meeting the highest standards of quality and consistency.
Float glass technology is a cornerstone in the production of high-quality glass products, serving as the fundamental starting point for various advanced applications. The process, aptly named float glass, involves the meticulous conversion of raw materials into pristine, defect-free flat glass. Let's delve into the intricate steps of this process, which is meticulously executed in state-of-the-art facilities. At the heart of the operation lies the float glass plant, a 24/7 facility where raw materials are transformed into clear, flat glass sheets. The journey begins in the batch house, where raw materials are rigorously tested, measured, and mixed to create a precise batch of dry ingredients. Additionally, the process embraces cullet recycling, where broken glass returned by customers is reintroduced into the batch, promoting environmental sustainability by reducing the need for raw ingredients. The culmination of the batch preparation process sees the materials conveyed into an immense furnace, reaching temperatures soaring up to 3,000 degrees Fahrenheit. Within this fiery chamber, the raw materials undergo a dramatic transformation into a pool of molten glass, which then gracefully floats atop a bath of molten tin. Here, the glass spreads into a wide, controlled sheet or ribbon, with skilled technicians overseeing the shaping and thickness adjustments. The final phase of the annealing layer, known as the mass air section, subjects the glass to a controlled cooling process, preparing it for cutting. Remarkably, the plant processes over 20 miles of glass ribbon daily, producing an impressive 600 tons of glass, with defects being a rarity thanks to advanced defect detection systems. Utilizing cutting-edge technology such as cameras, lasers, and specialized lighting, defects are swiftly identified and marked for corrective action. The cutting system meticulously slices around any flawed sections, ensuring only pristine glass moves forward in the production line. After scoring, the glass is snapped along the lines with precision, followed by edge trimming to ensure uniformity. Each glass pane then embarks on a journey through a computerized routing system, meticulously managed to preserve its pristine condition. Attention to detail extends to packaging, where careful handling ensures flawless surfaces, crucial for subsequent operations such as low-E coating. Laminated glass technology stands as a pinnacle in safety glazing, offering a multitude of benefits that make it indispensable in various applications. These glass panes are meticulously crafted by combining two sheets of annealed heat-strengthened or tempered glass with a robust interlayer. Through a process of applying heat and pressure, an inseparable bond is formed, resulting in a product that boasts enhanced safety features. The production of laminated glass involves a meticulous process that ensures both quality and reliability. Cardinal LG, a leader in laminated glass technology, has perfected this process to offer superior service to its customers. Starting from the delivery of float glass from their plants, the glass undergoes cutting, grinding, washing, and drying processes to prepare it for lamination. In a dust-free, temperature-controlled cleanroom environment, technicians meticulously assemble the glass panes with the interlayer. Through a two-step adhesion process involving high-temperature infrared ovens and autoclaves, the laminated glass achieves optimal bonding, durability, and clarity. Rigorous quality control measures, including online glass inspection, ensure that every pane meets the highest standards before packaging and delivery. One of the primary advantages of laminated glass is its resilience against breakage. Its construction makes it less likely to break, and even in the event of breakage, it remains intact, adhered to the interlayer, thereby reducing the risk of injury from sharp glass shards. This property not only ensures the safety of occupants but also maintains the structural integrity of buildings. Security is another aspect where laminated glass excels. The interlayer adds an additional barrier, making it difficult for would-be intruders to penetrate through the glass. This deters potential break-ins, providing peace of mind to homeowners and businesses alike. In environments where noise pollution is a concern, laminated glass acts as a sound barrier, dampening unwanted sounds and promoting a quieter atmosphere indoors. Additionally, it offers protection against harmful ultraviolet UV rays, which helps slow down the discoloration of interior furnishings and objects, thus preserving their aesthetic appeal over time. In regions prone to hurricanes or storms, laminated glass serves as a formidable defense. Specifically designed to withstand multiple impacts, it offers resilience against flying debris and harsh weather conditions. Even if the glass does break, the fragments remain adhered to the interlayer, ensuring the safety of occupants and minimizing damage to property.
The glass forming machine is a semi-automatic device designed for the production of standard and serial glass articles, with a specific focus on standard ground joints, ball joints, stopcock barrels, glass threads, and flanges. The machine is also suitable for forming tube ends of borosilicate glass, with a diameter of up to 120 millimeters. It offers several advantages that make it an efficient and reliable tool for glass forming processes. One of the key advantages of the glass forming machine is its PLC, Programmable Logic Controller, controlled operation cycles. This feature allows for easy programmability, and depending on the specific model, different programs can be stored and accessed at the control unit. This flexibility streamlines the production process and enables efficient customization of glass articles. Moreover, the machine can be equipped with a modem for remote control, adding to its convenience and accessibility. This feature allows operators to monitor and control the machine's functions from a distance, providing greater flexibility and automation. The glass forming machine is known for its high capacity and accuracy. This is achieved through finely adjusted forming tools, ensuring consistently close tolerances and reduced grinding times. The precision in forming glass articles is crucial for maintaining product quality and meeting industry standards. An important aspect of the machine's design is its ease of operation. Even semi-skilled personnel can handle the machine effectively, and in some cases, one person can manage multiple machines, depending on the operation hours of the program. This contributes to cost effectiveness and improved productivity. The machine's range of application is quite extensive, making it a versatile asset for glass manufacturing. From standard ground joints to various specialized glass articles, the glass forming machine covers a broad spectrum of glass forming processes. Laser processing offers a versatile and efficient method for working with glass materials, with various types of lasers being applicable for different applications. For volume engraving and marking of glasses, solid-state lasers emitting radiation in the visible and near-infrared range, around 500 nanometers to 1,100 nanometers, are employed. These lasers can create intricate designs within the glass volume and find applications in decorative and design-related industries. When glass needs to be heated for subsequent forming or joining processes, CO2 lasers are recommended. These lasers emit radiation in the mid-infrared range with a typical wavelength of 10,600 nanometers. At this wavelength, glass behaves as opaque, absorbing or reflecting around 80% of the emitted laser radiation on its surface, leading to efficient heating. In the glass industry, the automation of production processes has become crucial to survive in the global market and reduce labor costs. Laser technology has been successfully used in the automotive and metal industries for decades and can now be applied to glass processing. One of the key benefits is the high level of automation achieved with laser systems, making processes more efficient and reducing the need for manual labor. The flexibility of laser radiation makes it an ideal tool for various processes. By focusing the laser beam, precise cutting of quartz or scratching of borosilicate glass for subsequent thermal shock can be achieved. Alternatively, using larger laser beam diameters allows for effective glass heating, enabling possible forming and joining processes. Baccarat glassware is synonymous with luxury, elegance, and exquisite craftsmanship. The creation of each piece of Baccarat crystal involves a meticulous process that combines traditional techniques with modern technology. The hot process is the first stage of this remarkable journey, transforming raw materials into molten glass and shaping it into the desired form. Let's explore the various stages of the hot process and the skilled artisans behind this art. With the raw materials melted into a liquid state, skilled artisans, known as glassmakers, take over the process. They use a long hollow metal pipe, called a blowing stick, to gather the molten glass from the furnace. The pipe is carefully dipped into the lava-like glass, and the glassmaker turns it continuously to gather the right amount of material. Timing is critical during this stage, as the glass rapidly cools and solidifies once removed from the furnace. The glassmaker must work swiftly and efficiently to achieve the desired shape before the glass hardens. This requires coordination, experience, and an instinct for the right balance of movement and manipulation. Step 3. From lava to crystal. Once the molten glass is gathered on the blowing stick, the glassmaker begins shaping it into the desired form. At this stage, the glass is extremely malleable and can be manipulated using various techniques, such as free blowing or mold blowing. The tools used during this process are simple but effective. A wooden paddle is used to shape and manipulate the glass, a compass helps with measurements, and a pair of scissors is used to cut the glass. The real magic, however, lies in the skill and experience of the artisan. Each glassmaker must undergo years of training and practice to achieve the level of craftsmanship required for Baccarat glassware. Whether the glass is blown freely or shaped in a mold, the glassmaker must work swiftly and confidently. Achieving the perfect form often involves destroying imperfect pieces and incorporating them back into the raw material. An expert artisan can quickly assess the quality of the crystal and reject any flawed pieces without hesitation. Step 4. The transformation process. After the initial shaping, the glassware undergoes several transformations in the furnace. Each piece revisits the furnace multiple times to achieve its final form. Whether it's a delicate wine glass or an elaborate chandelier, every piece undergoes a carefully controlled heating and cooling process to ensure that all its components fuse seamlessly together. The furnace transforms the glass with an air of mystery and magic. The artisans may not fully see the final result until the piece is removed from the mold or expanded through skillful manipulation. It's like witnessing a captivating dance as the glass stretches and undulates to perfection. Once the hot process is complete, the glass is allowed to cool gradually to prevent any stress that could cause it to break. The slow cooling process ensures that the glass retains its structural integrity and results in a flawless piece of Baccarat crystal. The hot process is the first step in the creation of Baccarat glassware, setting the foundation for the intricate artistry that follows in the cold process. The dedication, precision, and artistry of the skilled artisans make each Baccarat piece a work of timeless beauty and elegance. The cold process. The cold process is the second stage in the creation of Baccarat glassware, following the hot process where raw materials are transformed into molten glass. In this phase, the molten glass is meticulously crafted into exquisite works of art, with intricate patterns, engravings, and gilding added to enhance its beauty. Let's explore the various stages of the cold process and the skillful artisans who turn rough crystal into sublime creations. Step 1. The first finish. After the glassware has gone through the hot process and has been shaped into its initial form, it enters the first stage of the cold process. Each piece is thoroughly reviewed to ensure the highest quality standards are met. The glassware is then polished using an iron wheel under a constant flow of water and sand. This process smoothens the surface, preparing it for further refinement. Next, the piece is passed through a series of wheels made of wood, cork, and wool. The craftsmen skillfully guide the glassware against these wheels, imparting a delicate sheen and a silky texture to its surface. This step is crucial to achieving the exceptional clarity and brilliance that Baccarat glassware is renowned for. Step 2. Wheel engraving and acid etching. In the cold process, artisans employ various techniques to add intricate patterns and designs to the glassware. Wheel engraving is one such method that originated in Baccarat in 1839, inspired by Bohemian techniques. It involves using a copper wheel to meticulously carve into the surface of the crystal. The process of wheel engraving demands a steady hand and an artistic eye. Artisans create straight or crossed lines and even intricate geometrical patterns by guiding the glassware against the spinning copper wheel. The result is a stunning design that enhances the beauty of the crystal. Another technique used in the cold process is acid etching, which was introduced in 1864. Acid etching allows artisans to create more elaborate engravings, including delicate arabesques and lettering. The artisan applies acid to the glass, which bites into the surface, leaving behind intricate and elegant designs. Jean-Luc Bourguignon, a meilleur ouvrier de France, MOF, is one of the skilled craftsmen who excel in these intricate techniques, creating awe-inspiring patterns on Baccarat glassware. Step 3. Gilding. Some pieces of Baccarat glassware undergo gilding, a process that adds a touch of opulence and luxury. Artisans use a mix based on gold powder, which is delicately applied to the glassware using a paintbrush. The gold powder is mixed with a matte enamel, and the artisan's breath is used to control the moisture and heat needed to set the mixture. The delicate art of gilding embellishes the most prestigious pieces, adorning the personal services of embassies, presidential residences, and custom orders.
In this section, we will explore the lead filament lamp production processes. Lead chip assembly. The process begins with assembling the lead chips onto a substrate, typically made of materials like ceramic or aluminum. This involves precise placement and soldering of the lead chips onto the substrate to form the filament structure. Filament welding. Once the lead chips are assembled, the filaments are welded together to form the desired filament arrangement. This welding process ensures proper electrical connectivity and stability within the filament structure. Phosphor and glue application. The filaments are then coated with a layer of phosphor, which converts the blue light emitted by the lead chips into white light. Additionally, a special glue is applied to secure the phosphor coating and protect the filaments from damage. High-temperature aging. The assembled filaments undergo a high-temperature aging process to stabilize their performance and ensure longevity. This step helps identify any potential defects or weaknesses in the filaments before further processing. Filament rack welding. After aging, the filaments are welded onto racks or supports, which provide structural integrity to the filament assembly and facilitate handling during subsequent manufacturing steps. Testing. Quality control checks are performed to verify the electrical and optical properties of the filaments. Bulb sealing. The filament assembly is then encapsulated within a glass bulb, which is sealed to create a vacuum environment or filled with inert gases such as helium. This sealing process protects the filaments from external elements and ensures optimal performance. Following the assembly of the filament, the glass bulb is sealed to create a vacuum environment or filled with inert gases such as helium. This step is crucial as it helps enhance the longevity and efficiency of the lead filament lamp. The vacuum environment or inert gas filling protects the filaments from oxidation and ensures stable operation. Additionally, the choice of gases like helium can influence the thermal conductivity within the bulb, aiding in heat dissipation and overall performance optimization. Drive assembly. The electronic drive components, including the driver circuitry and heatsink, are assembled onto the bulb base. This drive assembly provides the necessary power and control to the lead filaments for proper operation. Base welding. The bulb base is welded onto the sealed glass bulb, completing the assembly of the lead filament lamp. Aging. The finished lamps undergo another aging process to further stabilize their performance and ensure reliability before being packaged and distributed to customers.
Mechanical engineering in the glassmaking industry, exploring the glassmaking industry at a leading glass manufacturer. The focus is on the seamless integration of mechanical engineering and glass production. The facility operates 6 production lines 24/7, making it the only glassmaker in New Zealand. The process is complex, requiring meticulous attention to technical and production factors to ensure efficiency and quality. Raw materials used in glass production include sand, soda ash, limestone, and recycled glass. These materials are carefully elevated into batch hoppers and then melted at an incredibly high temperature of 1,600 degrees Celsius to create molten glass. This stage demands precise control to obtain the desired properties of the glass. Once the glass reaches its molten state, it is shaped into gobs, which are then loaded into the blank side of the machine. The gobs are pressed or blown into a parison, a miniature version of the final product. The mechanical engineering aspect comes into play here. as the machines require intricate design and maintenance to ensure accurate and efficient forming of the glass. A vital component of the glass-making process is the maintenance of molds used to shape the glass. Skilled technicians perform various tasks, such as spray welding, to repair any damages. The repair process demands precision and attention to detail to maintain the mold's accuracy and consistency. The apprenticeship program offers aspiring engineers a comprehensive understanding of both mechanical engineering principles and the glass-making industry. Apprentices learn about various machines, their functions, and how to optimize their performance. Additionally, they gain hands-on experience in mold maintenance, an essential aspect of ensuring high-quality glass products. Safety is paramount in the glass-making industry, given the extreme temperatures and potential hazards involved. Workers receive the appropriate protective gear and adhere to strict safety protocols to minimize risks during the manufacturing process. Continuous innovation drives the glass-making industry forward. Engineers and technicians are consistently seeking ways to improve production processes, reduce waste, and enhance the overall quality of the glass products. This includes experimenting with new materials and techniques to create innovative and environmentally friendly glass solutions. The collaboration between mechanical engineers and glass-making experts is crucial to the industry's success. It ensures that technical expertise is harmoniously applied to the complex process, resulting in the production of diverse glass products that meet the demands of consumers in various sectors. The glass-making industry's growth offers promising opportunities for mechanical engineering graduates. With a shortage of skilled workers, those with the right qualifications and training can find a rewarding career in this dynamic field. As the industry continues to evolve, it will remain a fascinating intersection of technical prowess and artistic creativity, producing a wide array of glass products that enrich people's lives in New Zealand and beyond.
Handling glass requires careful attention to ensure safety and prevent breakage. Whether working with delicate glassware or large panes of glass, proper techniques are essential to avoid accidents and damage. First and foremost, it's crucial to wear appropriate protective gear, including gloves and safety glasses, to shield yourself from potential shards if breakage occurs. When transporting glass, use both hands to support it evenly, distributing the weight and reducing the risk of it slipping or breaking. Large pieces of glass should be carried vertically whenever possible to minimize the chance of flexing and breaking under their own weight. When setting glass down, always do so gently on a flat, stable surface to avoid sudden impacts. Using padding or cushioning material beneath the glass can provide an extra layer of protection against accidental damage. Additionally, be mindful of the environment in which you're working. Avoid placing glass near edges or in areas where it could be easily knocked over. When cutting or manipulating glass, use appropriate tools and techniques to minimize the risk of breakage. Score glass carefully with a glass cutter before attempting to break it along the scored line, and use tools specifically designed for cutting and shaping glass.